Hello everyone and welcome back to Fleming's Math. This video covers the Unit 6 quiz review number 2. Starting with number 1, it says find the solution of the differential equation dy over dx equals 2x over x squared plus 1, which passes through the point 0, 3. In this first section, we let y equal the antiderivative or integral of 2x over x squared plus 1 dx. We'll use u substitution, and u is going to be this x squared plus 1. That means du is going to be the derivative of x squared plus 1, which is 2x, times dx, of course. So du is 2x dx, and we notice that we have 2x dx in the original problem, so we don't need to multiply this by anything. So let's go ahead and rewrite our integral. In section 2, it's just going to be the integral of 1 over u du. The integral of 1 over u du is the natural log of u, and u of course is x squared plus 1, and you add your c. Now in the next step, in step 3, we realize that when x is 3, when x is 0, y has to be 3. So let's just substitute 0 in for x, and then we'll set it equal to 3 here. So that's the natural log of 0 squared plus 1 plus c has to equal 3. That gives us the natural log of 1 plus c equals 3, and we know the natural log of 1 is 0. That gives us c equals 3. Then we write our final equation, and that is y equals the natural log of the absolute value of x squared plus 1 plus 3. Final answer. Here's number 2. It says evaluate the integral from e to e squared of 1 over x ln x dx. In section 1, we'll use u substitution, and u is going to be natural log of x. The derivative of u, or du, is 1 over x dx. Now I'm going to go ahead and change my limits of integration so that I can leave the problem in terms of u and not switch back to x. So u1 is going to be the natural log of x, where x is e. So if I replace e, or replace x with e, then u is going to be the natural log of e, which we know is 1. And then the second u value is going to be when I replace x with e squared. So the natural log of e squared is just going to be 2. And the reason is the natural log and the e, they just cancel each other out. So the natural log of e is 1, and the natural log of e squared is going to be 2. These are going to be my new limits. So here we are in section 2. Our new limits are integral from 1 to 2 of 1 over u du. The integral of 1 over u du is the natural log of the absolute value of u, and then we'll evaluate between 1 and 2. So first let's plug in 2 for u, and then plug in the 1 for u, and that gives us the natural log of 2 minus the natural log of 1, and we know the natural log of 1 is 0. And so our final answer is just the natural log of 2. Number 3, the integral of 5x to the 4th over x to the 5th minus 3 dx. Here in section 1, we're going to use u substitution, where u is x to the 5th minus 3. Then du, which is this derivative, is 5x to the 4th dx. And we have 5x to the 4th dx in the original problem, so we don't need to multiply this by anything. We'll set up our new integral, and that's going to be the integral of 1 over u du, and that is equal to the natural log of the absolute value of u plus the constant, and then finally replace u with x to the 5th minus 3. And so your final answer is the natural log of the absolute value of x to the 5th minus 3 plus your constant. Here is number 4. We have x squared plus 5x minus 12 divided by x minus 2 dx. Now I'll take a little bit more time to explain this one because this does require long division. It requires long division because the degree of the numerator is larger than the degree of the denominator. So our divisor is going to be x minus 2, which we will put outside. Okay, and then the dividend, that's the part that goes under the division sign, is the numerator, x squared plus 5x minus 12. Now the acronym for this process is DMS, which stands for divide, multiply, subtract, and then we just repeat that cycle. Alright, so the first thing we do is we take this x squared and we divide it by the x. So x squared divided by x is going to be x, which I will put at the top. Now I'm going to multiply, so we're on m now. Multiply x times x minus 2. X times x is x squared, which you will put underneath its like term. And then x times negative 2 is negative 2x, which goes under its like term. Now you're going to draw a line and put a parenthesis around this group, and now we're going to subtract. We're going to subtract this entire group. That's the s part of the DMS. Now x squared minus x squared cancels out, and we want to be careful here because we're doing 5 minus negative 2. That's 5x minus negative 2x is going to be positive. That changes to plus 2, so 5 plus 2 is 7x. And then you want to bring down the negative 12. Alright, that completes the cycle. Now we will start over with the D, which is divide, and we are dividing 7x by x. That's going to give us 7. And so we put that as a plus 7 at the top. Now we go to m, which is multiply 7 times x minus 2. 7 times x is 7x, and which we put here, and then 7 times negative 2 is negative 14, which we put here. We'll draw a line, parentheses around this group, and subtract. 7x minus 7x cancels out, and negative 12 minus negative 14, which is actually plus 14, is going to give us 2. Now x cannot go into 2, or I should say 2 cannot be divided by x, so that tells us that we are finished and that 2 is just our remainder. So what do we have? We have x plus 7, which is our quotient. So we have x plus 7, and we're going to integrate that, x plus 7 plus the remainder of 2 divided by your divisor, x minus 2. And of course add the dx on the end. Now we're just going to integrate this expression one at a time. Let's integrate x. The integral of x is x squared over 2. The integral of 7 is 7x. And think of this as 2 times 1 over x minus 2. Now we know the integral of 1 over x minus 2 would just be the natural log of the absolute value of x minus 2, and then that's just being multiplied by the 2 on the top. So that's plus 2 times the natural log of x minus 2 plus your constant. And that is your final answer. And here's question number 5. The integral from 0 to pi over 2 of the cosine of t over 1 plus sine t dt. We will use u substitution, and we're going to let u equal the denominator, which is 1 plus sine t. The derivative of that is du equals cosine t dt. We do have cosine t dt in our problem, so there's no need to multiply both sides by anything. Now I am going to change my limits of integration. so that I don't have to switch back to t. So when t is 0, well, let's start with when t is pi over 2. When t is pi over 2, u is going to be 1 plus the sine of pi over 2. The sine of pi over 2 is 1, and 1 plus 1 is 2. So when t is pi over 2, u is going to be 2. Likewise, when t is 0, u would be 1 plus the sine of 0. The sine of 0 is just 0, so u would just be 1. So my new limits is going to go from 1 to 2. So in section 2, let's just go ahead and rewrite this. I forgot to put those limits on there. That should be integral from 1 to 2 of 1 over u du. The integral of 1 over u du is the natural log of absolute value of u, and we're going to evaluate that between 1 and 2. So plug the 2 in first, and then plug in the 1 and subtract. We do know that the natural log of 1 is just 0, so we have the natural log of 2 minus 0 is just the natural log of 2 for your final answer. And number 6, the integral of 9 raised to the negative 4x dx. We will use u substitution. We're going to let u equal the exponent of negative 4x. So the derivative of that is du equals negative 4 dx. And we want to undo the negative 4 because here is the dx, so we need to get rid of that negative 4. So we'll just multiply both sides by negative 1/4. So we have negative 1/4 du equals dx. In this section, we're rewriting the integral with the pulling the negative 1/4 out in front, and that's going to be the integral negative 1/4 integral of 9 raised to the u du. Now we know the integral of 9 to the u is 1 over ln 9 times 9 to the u. And then we multiply that by the negative 1/4 in front and add our constant. Bringing this all together, it's going to be negative 9 raised to the u over 4 natural log 9 plus the constant. And then of course we change the u back to negative 4x. So our final answer is negative 9 raised to the negative 4x over 4 times the natural log of 9 plus a constant. Now if you looked at another answer key, you'll notice that they went a couple of steps further than this, but that is not necessary. If you get this far, this would be enough for your final answer. And there's number 7, the integral of 2 raised to the x to the cosine of x times the sine of x dx. Using u substitution, we'll let u equal this exponent, so u is the cosine of x, and the derivative, or du, is negative sine of x dx. In the problem we have sine of x dx, so we do want to get rid of the negative, so let's multiply by negative 1 on both sides, and that gives us negative 1 du equals the sine of x dx. Rewriting our interval, we put the negative 1 on the outside, so that's negative 1 times the integral of 2 to the u du. The integral of 2 to the u is 1 over the natural log of 2 times 2 raised to the u. We multiply that by the negative 1, and then we add our constant. Bringing that all together, it's just going to be negative 2 cosine of x, that's because we changed the u back to cosine of x, over the natural log of 2 plus our constant. And number 8, the integral of 1 minus cosine divided by sine theta d theta. First, let's rewrite this as two separate fractions, so that'll be the integral of 1 over sine minus cosine over sine. Now we know that 1 over sine is actually just cosecant, And we also know that cosine over sine is cotangent. So the integral becomes the integral of cosecant theta minus cotangent theta d theta. Each one of these has its own integral or its own antiderivative, which will be provided for you on the quiz. The integral of cosecant is negative natural log of the absolute value of cosecant theta plus cotangent theta. And the integral of cotangent is the natural log of sine theta. And then you just add your constant. So this is your final answer. Here's question number 9. Evaluate the integral from negative radical 3 to 0 of x over 1 plus x squared dx. Using u substitution, u will be the denominator of 1 plus x squared, and the derivative of u is 2x dx. Now we have x dx in the problem, so we do want to get rid of the 2, and we'll multiply by 1/2 on both sides to get rid of the 2. So 1/2 du equals x dx. I am going to change my limits of integration here so that I don't have to switch back to x. So I notice that when x is 0, the top limit, u will be 1 plus 0 squared, which is 1. Likewise, if x is negative square root of 3, then u would be 1 plus negative square root of 3 squared. Well, that's just going to be 3, plus 1 makes 4. So these are going to be my new limits. When x equals 0, u is 1, so 1 is going to be the upper limit. And when x is negative square root of 3, u is 4, that's going to be the lower limit. So in step 2, it's going to be 1/2 of the integral from 4 to 1 of 1 over u du. We know the antiderivative of 1 over u is the natural log of the absolute value of u with the 1/2 in front, and then we'll evaluate that between the 4 and the 1. We will plug in the 1 first, and then plug in the 4 and subtract in between. So that's 1/2 of the quantity natural log 1 minus the natural log of 4. And we know that the natural log of 1 is 0, so this would be negative 1/2 natural log 4. Now that is an acceptable answer. However, we could simplify this further using rules of logs. We could change the 4 to 2 squared, and then move the 2 out in front, and it would multiply the 1/2. So the 2 and the 1/2 would cancel, and then you just have negative natural log of 2. And that would be another acceptable answer. So we will take either one of these, negative 1/2 natural log 4 or negative natural log 2. Alright, here's our last question, number 10. Find the differential equation, or solve the differential equation. dy over dx equals e to the negative 2x over 1 plus e to the negative 2x. And using u substitution, we're going to say that u is 1 plus e raised to the negative 2x. Now, to solve the differential equation, y is going to be the integral of this expression. Alright, so u is 1 plus e to the negative 2x, so the derivative is du equals e to the negative 2x times negative 2 dx. Oh, times negative 2, yeah, that's because of the chain rule, right? Okay, now when we look at what we have here, we have e to the negative 2x dx, and so we would want to cancel out the negative 2, so we'll multiply both sides by negative 1/2. That gives us negative 1/2 du equals e to the negative 2x dx. Okay, in the next section, we're just rewriting. We pull the negative 1/2 out in front, times the integral of 1 over u du, and that's going to give us the negative 1/2 times the natural log of u plus c. And of course, u has been replaced with 1 plus e to the negative 2x. And this would be an acceptable final answer. However, again, looking at another answer key, they went further in this fashion. They took the 1/2, brought it up here as the exponent. So now the 1/2 is the exponent of this expression. And of course, raising something to the power of 1/2 is the same thing as taking its square root. So that's how they ended up with that alternate answer. Negative natural log of radical 1 plus e to the negative 2x plus your constant. And as I said, either one of these answers would be acceptable.